Okay, now we'll start. Good evening, girls. Now, am I audible?
Yes, ma'am.
Okay, ma. We'll wait for 5 minutes. Most of them trying to join. Yes. Yes, now we start the revision class. Most of the students are joined. So, most of the students are asking me about the problems first. After that, we'll start a revision with the fifth unit and also remaining units. So, we'll start with the problems now first. Is it audible to you?
Yes, ma'am.
Okay, ma. We'll start with the disk scheduling algorithms. Last unit, in that only the problems are disk scheduling algorithms. Okay. So generally our disk is in the shape of circular. That we will call it as platter actually. This we can call it as platter. Every platter is divided into the number of circuits. And to read the data, they are having the read-write head. This is the head, that we can call it as read-write head. So when this head touches the disk, where it touches, that part of data we can read or write. So for this scheduling algorithms, what we are doing here means we are reading or writing the data in the disk. If you are already stored data is there, we are trying to read. If you want to write first time, if you want to store some data that first time, that we are calling it as write. To store that data, generally hard disk is in the form of this shape, circular shape. And again it is divided into the number of circles. This every circle we can call it as cylinder. And this is again divided into the parts, into equal parts. This equal part we can call it as a sector. We can call it as a sector. To read the data or to write the data in a particular place, this equal partition sector. So this head need to move. So here disk scheduling algorithm is about the read-write head moving to the particular cylinder first, after that sector it will try to read. So disk scheduling algorithms is related to read-write head moving to the particular cylinder. So this is a platter. Every platter is divided into the number of equal circuits like this. So here we are having read-write head. If read-write head touches the particular part, there we can read or write. So to read or write in a particular place, first here this head moves in this angle or in this angle. If it is in a particular position here, whatever the data, wherever the data, if you want to read or write in this particular place, then this read-write head needs to move from this place to this. So these we can call it as cylinders. So this scheduling algorithm is related to this one. To the time it is required to move this head from the current position to the particular target position, that we are calling it as seek time. So to find the seek time in this scheduling algorithms, how many cylinders it is traveled, that we are trying to calculate. That are related to the disk scheduling algorithms. There are different type of disk scheduling algorithms are there. So these are related problems in the 5th unit. First we'll revise the problems. After that we'll go to the theory part. So this is the basic information about the disk scheduling algorithms. Magnetic disk is divided into the number of cylinders. There is a read-write head. To move that read-write head from current position to move the read-write head from the current position to particular required desired sector or desired cylinder, how much number of cylinders it needs to travel, how much time it is required to travel that one, that we are calling it as seek time. And here we are trying to calculate how many number of cylinders it is traveled to the desired cylinder, that we are calculating. For that purpose they will give you the input of work of cylinders to read the data or to complete or to store the data or to read the data in one file, how many number of cylinders in which sequence it required, that are how many number of cylinders it needs to travel to read the data or to store the data related to the particular file. They will give you that information, that we are calling it as Q, work Q. To read the particular data or to store the particular data, how many number of cylinders the read-write head need to travel, that they will give you the information. So this is the work queue. And where is the current head position? Where is the current head position? In which cylinder the head position is there, that also they will give you. So simple, head position is at 53 cylinders. So I said platter is divided to the number of cylinders. Here for this example we are considering 200 cylinders are there. That will start from cylinder 0 index to 199. 199, and now they will give you the position. This current read write head is at the 53 cylinder, and to store the data, to read the data, particular number of cylinders they gave in the form of cylinder numbers. That cylinder numbers they will store in the data structure work queue. So this is the work queue position that I will give you here. 98 cylinder number it required to read or store the data first. After that 183, 40 it required, 122. Example purpose I am taking all these things. 10, 124, 65. To read or to store the data, it requires need to travel these number of cylinders. 98 number cylinder number, 183 cylinder number, 40 cylinder number, 122 cylinder number, 10 cylinder number, 124 cylinder number, 65 cylinder number. Now our current head position is at the 53 cylinder. So to satisfy all these requests, to store the data, to read the data, it needs to move. Operating system needs to move that head to all these cylinders. For this, how many number of cylinders it required according to the different algorithms. Different techniques are there that we are calling it as disk scheduling algorithms. That are, first disk scheduling algorithm is FCFS, SSTF, after that scan, C-scan, look and C-look. These are the different disk scheduling algorithms are available. So available according to the FCFS scheduling technique, how head will move from one cylinder to another cylinder to satisfy all these requests. That is the FCFS algorithm. To the FCFS scheduling algorithm is first come first serve. First come first serve. First come first serve. First come first serve. According to this scheduling, it will satisfy the request whichever first come. So in this work queue, 98 is the first request. First request to read or write the data regarding to the any file or any program. Regarding to that one, it required first request is 98 cylinder it want to move. So what is the current position now? 53. To understand how many number of cylinders it traveled, to understand that, according to the first come first serve FCFS scheduling, I am writing like this: cylinder numbers in a horizontal one. I said according to this example, there are platter is divided into the 200 number of cylinders. So that's why I am starting with the 0, ending with the 199, and our head position is at 53. And according to this work queue, what are the number of requests are there? Means there is a 98, 183, 40, 122, 10, 124, 65. So here after the 0, hot cylinder comes according to the work queue. Here it is 10. After that 40. After that 40. Next, according to this work queue, 53 is our head position. Next will come 65. In sequence manner, I am writing the cylinder numbers here. After that, it will come 98. I am not particular distance, I am not writing here. Simply I am writing the cylinder numbers here. So after this 65, 98 is there in our work queue. Request to read the data, to store the data on that cylinder number. So 65, after that 98 is there. After that 122, 124 and 183. These are the cylinder numbers it needs to travel to satisfy the request from the user to read or write the data. This cylinder is physically where we will store the data on the disk. That is one part of address. Again, it is divided into the sectors I said. But according to the scheduling algorithm, first head needs to move to the particular cylinder. How much time it is required? That is how much time it is required means how many number of cylinders it traveled within the particular time, that we are calling it as seek time. But according to this scheduling algorithm, here we will try to calculate how many number of cylinders it traveled from current position to the particular one. So according to the FCFS schedule, first come first serve, it will serve the request which is first request in the work queue, which is the first request cylinder number to read the data or write the data. So from the current position to, it will to move to the first request 53 through 98. After that, next request is 183. It will move to that one. Next request is 40. It will move to that position head. Here it is moving in this manner from 53 to 65. 198 means maybe somewhere here. After that, it is again it is moving to the 122 means somewhere here. It is divided into the 200 cylinders. Okay. After 98, 183 is there. It moves to the 98 to 183. 183 to next request is 40. 40 after that it is again request is 122. After that again request is 10. Next it will move to the 124. According to this, last is 65. Last is 65. So like this, it will satisfy the request. Here we said number of cylinders it traveled head position to satisfy all the requests that we are calculating. That means it is now a first current position of the head position is at 53. So to serve the first request, it is moved from 53 to again 98. How many number of it is traveled by the to serve the first request means 98 minus 53 number of cylinders it traveled. Like that, to serve all the requests, how many number of cylinders it is traveled means for after that every request we need to calculate the number of cylinders. 98 minus 53. After that it served the 183. 183 minus 98. Like this, total number of cylinders it traveled that we need to calculate. According to the FCFS, how many number of cylinders it traveled, that we will write it as total number of cylinders traveled by the disk head to satisfy these requests which are specified in the work queue according to the FCFS scheduling, that we need to write. First, what is FCFS we need to write? First come first serve. According to that, it will serve whichever come the first request, for that only it serves that one. That means it provides the service, that we need to write. After that, these calculations. After that, last step is total number of cylinders it traveled according to the FCFS scheduling. That also we need to write. Is that clear, everyone? Any one of you respond, please.
Yes.
Yeah, okay. Thank you, ma. If you are responding, then only I will understand you are listening or not. Next, we need to move to the revision class 1. That's why I am continuing with this speed. Okay? Yes, ma. So that is according to the FCFS. Second technique is this one is shortest seek time first. Shortest seek time first. Shortest seek time first means from the current position, all these requests, how many requests are there means 1, 2, 3, 4, 5, 6, 7 requests are there. In this 7 requests, which is nearer one? For that it will serve first. For that it will move to that cylinder to read the data. To write the data on that cylinder. So that's why according to shortest seek time, what it is, which one is nearer request to the current head position, that we need to check in that work queue. So here our head position is at 53 and these are all work queue requests are there in this. So within that, which is nearer one, we'll check with the 53, 40 or 65. Maybe any one of these is nearer to current head position. 53 minus 40, it requires 13 cylinders it needs to travel to serve from current position to this position. Otherwise, 53 to 65. 53 to 65, which is the next request, may be nearer to that one. That we need to calculate. How many number of cylinders it needs to travel from 53 to 65? How many number of cylinders, ma?
12.
Yes, 12. So which is nearer one?
12, ma'am.
Yes, to the current head position. That's why it will take that operating system decision from current head position to which is nearer one, 65. That it will serve first. So it reads or write the data on that 65 number of cylinder, cylinder number 65. After that also, now this is the current head position. Again it will check in this work queue which one is nearer. Automatically in this direction which one is nearer, that one only. In this direction whatever the request is there, that may be nearer to. Maybe we'll check from the 65 is 40 nearer, or from the 65 with 98 is nearer one, ma?
98, ma'am.
So then it will move from current head position from 65 to 98. After that again same position from 122, 130, 124 and 183. So it will check that one and it will move from current head position to the next position. First time it is current head position is 53. After that first request, current head position is 65. After that next request, current head position is 95. After that 122. Next 124, 183. After that remaining requests are in work queue is only 40 and 10 is there. Only remaining request is 40 and 10. Then automatically which one is nearer from 183 to 40 or 10? Automatically it is nearer one is 40. Next 10. How many number of cylinders it traveled? We will check easily. 183 minus 53. That means how many number of cylinders it traveled first is 50 to serve from this to this. After that 183 minus 40 and 40 to 10. So this one is 30. This one is again 143 plus 50. So these many number of cylinders it traveled to serve the all this request. To serve all this request. 65 is nearer to 40 or 98, ma?
40, ma'am.
40. Then it will move that one. Not in this direction. Then it will move this one. What is the difference between 65 and 98?
33.
33. And this 25. That's it, na? 65 to 40? Yes, ma. That's why. So, maybe from 53 to 65, in between these two, it is the nearer one. So, in between these two, every time it needs to check that one. If it is nearer, which one is nearer? 40 is nearer. Then it will move from 65 to 40, not 98, because this distance between these number of cylinders is less. After this, which one is nearer from 40 to 98 or 40 to 10? 40 to 10 is 30. Here 40 to 98 is 58. Difference between 42 and 98. So 53 to 65, 65 to 40, 40 to 10. After that 98, 122, like that it will move. So every time from current head position to which one is nearer, that we need to check. That we need to check. That's it, ma. So is someone said from 65 to 98. That's why I started in this direction actually. But from the 65, 40 is nearer. So it will start in this direction. Like that it will serve in shortest seek time. So according to FCFS, shortest seek time is will get the less number of cylinders it will travel. We'll check with the count, then you will get that answer. This is the technique FCFS. After that, shortest seek time first. Every time from the current head position, which request is nearer. For that it will serve. That is SSTF. Shortest seek time first. So the FCFS advantage is first request will be first server. That is advantage of FCFS. Disadvantage, more number of cylinders it needs to travel all to serve all the requests. That is the disadvantage of FCFS. SSTF is shortest seek time first. By this advantages, every time it will check which one is the nearer. For that only it will serve. That's why total number of cylinders traveled to serve all the requests will be less. That is the advantage of SSTF. That also we need to write. After that, scan. So scan is another name for the scan is elevator algorithm. It follows the elevator concept. It will start in one direction. It will serve all the requests in that direction first. Till the end it will go. After that it will come in reverse. That it follows the elevator concept. That's why it is giving the one more name for this scan algorithm is elevator algorithm. Elevator algorithm. Please explain file implementation and trade-offs. Anyway, I'll explain ma. First, I'll complete this scan and everything. After that, I'll continue with the RAID and remaining structures also related to fifth unit. Okay. So this one is about the elevator algorithm. Scan algorithm, I said in any one direction from the current position till satisfy all the requests, maybe the left side or right side. And it goes to the end. After that comes back to the reverse manner. And also one more thing is there here. One more thing is here. What it is, sometimes they'll give you the information to the direction. Sometimes they'll give you the information about the direction is need to move to the higher number from the current position. 53 to higher number. They'll give you that information means we need to move from 53 to 199 direction. Otherwise, they'll give you that information need to move from current position to the less number. That means we need to move from 53 to in this direction to serve all the requests. They'll give that in this information also sometimes only. Not all the times. That is the one time they'll give you. One more type of thing they will give you to know the direction. That is what is the previous request. What is the previous current position of the head. Now head is at the 53 position. They'll give you that information. Previously it is at 40 direction. 40 cylinder. Previously served request is maybe the previously served request may be the 45, maybe the 45. Previously served request also they'll give you that information. That means previously is head is at 45 and it moved to the 53. It moved to the 53. That means in which direction it is moving from lower number to higher number. Then we'll take this one. Now work your requests are this one. Previously head is in this direction only. That's why we'll continue till the end in this direction. Now head is at the current direction. Current head position is at 53. After that it serves 65. After that it serves 98. After that it serves 122, 124, 183, 199 also it will reach. 199 is not in the work queue. But according to the scan algorithm, it will reaches the end, till the end. It will reaches till the end. After that, it will comes in reverse manner. It satisfies all the request 183 and what is the end cylinder number is 199. And it will move from reverse direction and what are the remaining requests are there? After 199, 40, 10. This is the last request in the work queue. How you know this one is the direction? Any one direction it can move. But how you know to move the head position from in this direction means because they gave the information about the previous request. Already previous request is 45. It served that one and it moved from 45 to 53. That means head position is moving in this direction. That's why we took this direction and it completed. Last request in this direction is 183. 183. But according to the scan or elevator algorithm, it needs to move till end and it will start in the reverse direction. It will start in the reverse direction. That's why it will reach the till end 199 and it will start the reverse direction and remaining request. What are on the way? On the way it is 40. After that on the way it is 10. So it satisfies all the requests. Clear ma this one scan?
Yes, ma'am.
Yes, ma'am. Okay, so these are the things they will give you the information about the direction. If they are not specifying any one direction you can take and you can continue with that. This is about the scan. You can calculate the number of cylinders, how many number of cylinders it traveled means the difference between all the head positions. That is okay. Next one is the C scan. C scan is circular scan. C scan is circular scan. So it is considering it is in a circular manner only. Anyway, platter is in circular manner only. But while it is moving also, it will consider it is we need to move in circular manner only. Maybe the clock direction or anti-clockwise direction. For this also, these are the things it will give you. Previous request information, otherwise direction towards the higher number, direction towards the lesser number also, that information also they will give sometimes. Otherwise, you can take any one of the direction. If we are taking the same thing, previously it is served with the 45 and it is continued, now it is at the current position at 53. In second mid, I gave this type of question only for you people. Previous request and what is the current request. In this direction only, to know the direction, they will give you that type of information. If it is 45 and 53, in this direction. Otherwise, sometimes they will give you the information, previously served request is 60. That means head is moved from this to this. Then we need to move in this direction. So depending upon the previous direction, sometimes you will know the what is the direction you need to move. So according to the circular scan, according to the C-scan, circular scan, it will consider it as in the manner of circle. In the manner of circle. So now we are considering this one only. Previous request is 45. Now it is at a 53. We need to serve all the requests which is in the queue, which is in the work queue. So same 53, 65, 98, 122, 124, 183 and 199. Scan, C-scan, moves till the end, till this point. After that, scan will comes in the reverse direction, but C-scan from 192 to other end. It will come to other end and it will start in this direction. So what is the next request is 10. That request is 40. It will move from 199 to 0. It is in circular manner. 199 after it will come 0 and it continues with the remaining direction. So while you are calculating number of cylinders it travelled head, no need to consider this number of cylinders. No need to consider this value. No need to consider this value. Simply 53 to 65, 65 to 98, 98 to 122, 124 to 183, 183 to 199. That's it. Stop there. And from 0 to 10, 10 to 40. No need this one. Simply no need of calculating this many number of cylinders. Simply it moves from 199 to 0 directly. And from 0, it will move ahead from 0 to 10, 10 to 40. No need of calculating this part for C-scan. Is that clear? Scan and C-scan. Scan, it will come in reverse. First serves the 40, after that 10 and stops there. But according to the C-scan, after 199, it will start from 0 and 10 and 40. This is according to C-scan. Scan, C-scan. We'll come to this one. This is C-scan. Till this point it is same only. Scan, it will come reverse and it serves 40, after that 10. But according to C-scan, 99, after that it will start from 0 to 40, 0 to 10, 10 to 40. 10 to 40. So this is about C-scan. Okay, ma?
Okay, ma'am.
Okay, ma. Next one is look. Look is just like the scan only, but it will not move to the till end, till the last request only, 183 is last request, current head position is 53, it will start it in this direction. After that, it will come back 40 and 10. No need of moving to the till the end. That is look. This is look. It will started in this direction, 53, 65, next serves 180, 98, 122, 124, 183. After that, in reverse direction, it will move 40 and 10. This is look. Again, C look. It follows the concept of C scan, but it is not in a circular manner. Follows the concept of C scan only, but it not a circular one. It not a circular one. According to the C look, current head position 53, 65, 98, 122, 180, 124, 183. After that, it will come back to 10 and last request in this direction and moves to 40. Here we need to consider this one also. While you are calculating number of cylinders head traveled, there we need to add 199 minus 10. Whereas in C scan we are not adding 199 minus 0. But according to this one, we need to add this one only. We need to add this one out. 199 minus 10. 199 minus 10 also we need to add in C look. 53, 65, 98, 122, 124. Look and C look both are same. In look it will come in reverse direction, but it's first it serves 40, after that 10. But in C look it will from 183 to it will come to the 10. And after that only in this direction it will start. 10 it serves first, 40 after that it will serve. Clear ma?
Yes, ma'am.
Yes. Okay. So this is about the disk scheduling. Most of your friends may miss this one. That's why I repeated this one. After that, which one you required ma? Page replacements problem or deadlock problem or CPU scheduling problem?
Ma'am,
Yes ma.
ma'am, in question paper, for
Ma'am,
ma'am,
in
you
digital
gave
Yes
one
ma.
processing,
question, ma'am.
synchronization.
In question paper?
For mid two, you gave one question, ma'am, like disk driver, current serving request is 143 and
Yes ma.
previous
Previous
request
request is?
125.
Ma.
So
That
we
means?
need to consider previous request in the
Direction, to know
when
the
we are doing.
direction, to know the direction. That means 125 to 143 it moved the previous. Then we need to serve the request which is after the 143, which is after the 143 in between the last one. So we need to move in that direction. But I gave the marks to in two directions. Where they did the in two directions to calculate that one, I gave the marks to you people. But in external exam, we need to consider this one to know the direction. To know the direction. Clear?
Okay, ma'am.
Okay, ma'am. And someone asked me about the deadlock sum. Is it okay?
Ma'am, deadlock and classical problems of synchronization.
Classical problems of synchronization also. That means this one, bounded buffer and this are all.
Yes,
That
ma'am.
one only. So before deadlock, I need to continue now. After that, RAID structure. Otherwise, I'll start with the RAID structure. I'll try to share this one. Or I'll start this deadlock, ma.
Rate structure, ma'am.
Most just give me the messages. How many members require deadlock or how many members require this one? RAID structure means I'll give you that information also. 1 second. I'll check this. I shared with you na RAID structure. Yes. Whatever I'm sharing, is it visible to you? Screen?
No, ma'am.
Okay. I'll check that one. 1 second. Otherwise, you are having notes, ma? Right structure notes? Is it visible to you now?
Yes, ma'am.
Okay, ma'am.
Yes,
This is
ma'am.
the RAID structure. RAID structure is used actually to minimize the cost as well as to increase the performance. And according to the speed, hard disk is having very less speed to transfer the data from hard disk to main memory to the CPU. CPU has the highest speed to perform the task, but it required the data to perform the task. So to transfer the data, when you need to transfer the data from hard disk where we store the data permanently, after that we'll move that data from hard disk to main memory. After that we are allocating to the CPU to do the some particular task. But speed of this to transfer the data is hard disk is very less and cost is also very less. To increase the speed, to increase the speed, to increase the speed of to transfer the data with the very to increase the speed of the data transfer from hard disk to the main memory, they are using the RAID type of structure. That means increasing the size of hard disk, and parallelly we are trying to transfer the data from many places from hard disk. In that also different type of disk will maintain, and from that we can parallelly we can transfer the data related to one file. We are dividing that file into and we are placing into two or more disks at a time, parallelly transferring the data from two or more disks to main memory. Instead of in one disk, they are maintaining set of disks to store the data, because it is very less cost. To increase the speed, parallelly from different disks, parallel operation we will do, transfer the data from different disk to the main memory at a time. Anyway, speed of the main memory is very high comparing with the hard disk. It is high comparing with the hard disk. So it will take that data, and to transfer the data speed with the speed, they are using parallel concept. Parallelly from the number of two or more disks, it will transfer the data to the main memory. After that, it will allocate to the CPU to do the performance. That structure we are calling redundant structure. What it is? RAID means it is a redundant array of independent disks, set of independent disks maintaining as a array. And in that, to store the data, to increase the speed, they are using different types of concepts. According to the concepts, they are divided into levels to store the data. That we are calling it as RAID levels. Redundant array of independent disks. Independent disks are maintaining as an array to increase the speed with the less cost to transfer the data. And how, what is the concepts are they are using to store the data, to transfer the data from this permanent storage to main memory, that are divided into the number of levels. To store the data and to transfer the data from this RAID independent disk to main memory, that it uses the two concepts, stripping and mirroring. So first level it uses the RAID 0 is stripped disks. Stripped disks. What is stripped disk means? We said it is a set of independent, array of independent disks. So it is taking 8 disks, and it is using 2 drives only. Complete hard disks are 2, and it is divided into the 8 parts. 8 parts. It is divided into the 8 parts. That is block 1, block 2, 8 blocks it is divided. Any one file is there. Any one file is there that it will store half of the file in block 1, half of the file in block 2. And whenever you want to complete the execution of that program or that file, read the file or write the file, automatically same time parallelly transfer the first part and second part at a time parallelly to the main memory. So one after another, it will take more time. Parallelly, we are dividing that file or program into the two parts. 20 set of instructions are there, 10 set of instructions in block 1, 10 set of instructions in block 2. Parallelly, we will transfer that 20 set of instructions within the less time, with how much time it is take to transfer the 10 set of instructions from hard disk to main memory. That in that time only we are transferring 20 set of instructions at a time by using the RAID 0 structure. That means every program, every file is divided into the two parts. First part is maintained in the drive 1, second part maintained in the drive 2 blocks. If it is program 1, block 1 and block 2, program 2, block 3, block 4, program 3, block 5, block 6, program 4, block 7 to block 8. That is the stripped concept. Is that clear? Divide into two parts, and parallelly we are transferring from hard disk to the main memory to increase the speed with the less cost. They used the structure of RAID. Here they are using only the two hard drives. That is divided into the 8 blocks. Every drive is 4 blocks. In 4 blocks, part of the data they are maintaining, second part of the data related to every file. Every file is divided into the two parts. First part in the first drive 1, second part it maintains in the drive 2. Parallelly, whenever the file or program required to read or access the data, the CPU will do the process at a time with the less time. That is the concept of RAID 0. Is that clear, ma?
Yes, ma'am.
Next one is RAID 1. RAID 1 level is, it uses the concept of mirrored disk. That means again here it is also using the two drives only, drive 1 and drive 2. Again it divides that one every drive into the 4 blocks only, but complete program maintained in block 1 as well as in block 1 of the second drive also. Block 1 first part, complete file is maintained in the drive 1 as well as drive 2. But we need to increase the speed. How they are increasing the speed here? Because here in first one, drive 1 also having the complete program, second one also having the complete program. But to transfer the parallelly, same thing, same example, 20 set of instructions are there. It will take 10 set of instructions from drive 1, remaining 10 set of instructions from drive 2, because it is also having 20 set of instructions. First one is also having the 20 set of instructions. By using this type of concept, they are transferring, they are increasing the speed to transfer the data from hard disk to main memory, to allocate that one to the CPU and to get that result within the less time. But here it is using the mirroring concept, means, because why it is maintaining the mirroring concept means, in previous one RAID 0 concept, they are maintaining in one drive part of the program only. If there is any problem with the hard drive 1, will having only the part of the programs of every file. Every file, second part only we are maintaining in the drive 2. First part will not get. So will not execute any file or any program. Because we are having only part of the data. That is the problem with the RAID 0. That's a to avoid that problem, they are using the RAID 1 structure. Here they are maintaining the backup. If there is any problem with the driver, anyway speed will decrease, but data is there in the drive 2 also. Full data is available related to every file. We are having complete data in drive 2. By that we can increase speed with the RAID structure. So that is the advantage of RAID 1. So it uses the two concepts. RAID 0 is stripping concept, dividing or partitioning data and storing in two drives. Instead of two drives, it can maintain 3 or 4 also. But according to the RAID level 0, they took only the 2 drives. And RAID 1 also, they took the two drives and avoids the problems when there is any problem, reliability problem. If there is any problem, will stop that complete processing, useless of every file. To avoid that one, here they are using the RAID 1 backup style. Next one is Next level is directly RAID 5. In this, they are using 4 drives, 4 hard disks, and every drive is divided into the 4 blocks. Every drive is related into the 4 blocks, and it uses the two concepts of stripped as well as mirror. In stripped, we are dividing the complete file into the parts, and in mirror, we are maintaining complete file in one place. So it uses the two concepts. See, first layer, block 1A, block 1B, block 1C, block B1. One program, first program, 1. In that, what they are doing, they are dividing complete program into the two parts. First part they maintain in the drive 1, second part they maintain in the drive 2, third part they maintain in the drive 3, and complete program they maintain in drive 4. They are maintaining backup as well as parallel concept. So it increases speed more comparing with the RAID 1 and RAID 0. Whenever you want to transfer the complete file, then parallelly with the 4 disks, first part, second part, third part, 3 parts within the less time, comparing with the 2 hours, we are dividing into the 3 hours. Within the 20 instructions, we will divide into the 3 parts. We'll divide into the 3 parts. So instead of taking the 10 set of instructions transferring from hard disk to main memory, it is taking more less time, because we divided into the 3 parts, means every part will contain less number of instructions, less than the 10. So it will take anyway less time. So it is having first part 7, second part 7, third part it is containing only 6 set of instructions. Instead of time taking to transfer the 10 set of instructions, here we are sending the data 7 set of instructions parallelly. It will take the less time. So this is the advantage with the RAID 5. It is having the backup also. If there is any problem with the any hard drive, anyway we are having one more backup. If there is problem with the drive 2, second part will miss, but we'll access second part from the drive 4. If there is problem with the drive 4 itself, we are having 3 parts of program, so we can continue our work. We are having complete file information in block 1, block 2, block 3. If there is any problem with the block 4, like this, they will avoid that problem and they can continue with the reliability. Is that clear, ma? RAID 0, RAID 1 and RAID 5?
Yes, ma'am.
So like that, RAID 0 is stripping, RAID 1 is mirroring concept, RAID 5 is it uses the stripped concept as well as mirroring concept. RAID 6, here instead of one part, they are maintaining in 2 parts at a time. See, green one. Our complete program is in drive 4, B1, block B1, and this is anyway, it is divided into the 3 parts only. First part they maintain in the drive 3, second part they maintain in the drive 2, third part they maintain in the drive 1. Drive 1. And also they maintain the second part here, and third part here, again next part here. So complete program is divided into the 1, 2, 3 parts. Complete program is available at the block 4. B4 means it is a complete file. Here anyway we are having the complete file, and these 3 parts are also 2 types. In block 1 is available in drive 3 as well as in drive 4. Block 2 is available in drive 3. See, green blocks, drive 3 as well as in drive 2. Block 3, green block, is available in drive 2 as well as available in drive 1. They are maintaining more backup comparing with the remaining one. Comparing with the RAID 5 structure, they are maintaining more backup in RAID 6. So to increase the speed as well as reliability purpose. Like this, these are the different structures are available. We need to write these blocks picture in representation as well as whatever I said now. That you need to write in the form of sentences. What is RAID? Redundant array of independent disks. Why we require this one? To increase the speed of the data transfer with the less cost. Whatever the material you are using for this disk is with the less cost. Size, we can more size will get with the less cost. And to increase the speed, we are using number of disks. That means we are increasing the size at the less cost, and also we are increasing the speed. with the less cost. So that's why they are using. Next will comes the nested RAID levels. Nested RAID levels means they can use 1 and 0, RAID 0 and RAID 1 concept simultaneously. This is the figure. See. These two are maintaining the concept of mirroring, drive 1 and drive 2. And drive 3 and drive 4 also same thing. They are maintaining the mirroring concept. First program is divided into the two parts. In drive 1 and drive 3 they are maintaining. And like that they will maintain all these things under mirroring and stripping concepts. Nested is combination of these two. Like that nested concepts are also 1 plus 0 is there and 0 remaining also there are few nested concepts are there. Is that clear, ma, with the RAID structure?
Yes, ma'am.
Okay, now everyone is clear? Simple concept this one. Figures you need to write and whatever the explanation I said, just you need to write that one. Okay, ma'am. So shall we start the deadlock problem now? Everyone is okay? Shall I continue? One more problem? Yes. Deadlock or page replacement you required first? Which one you required, ma'am?
Deadlock, ma'am.
Deadlock. Okay. So I'll write the deadlock problem here. So in deadlock, it uses the banker's algorithm structure. What is the banking concept is, whenever the request comes from the first customer, it won't satisfy if it is a big request. If there is 25 lakhs of request comes from the customer at a morning 10 o'clock. They started the bank at 9:30. One customer came with the 25 lakhs. He is having that much amount of money in his account. But he want liquid money, 25 lakhs of liquid money, and he customer came to the bank and he requested for 25 lakhs at 10 o'clock. Bank is also having that 25 lakhs of liquid money, but it won't give that 25 lakhs to the first customer itself at 10 o'clock because it needs to satisfy the customer request whichever comes after the 10 o'clock till the bank timings. If they are having liquid cash of 25 lakhs, he's in his account also 25 lakhs is there. If bank gave that 25 lakhs to the first customer itself, remaining customer who is coming at the 11 o'clock for the simple 100 rupees liquid cash, then also they are not able to satisfy. That's why they won't satisfy that. They won't allow that request. They will maintain at least safe amount. Then only they will allocate according to their request at least part of that request. Otherwise, they will deny that request. So, where the customer comes with the 25 lakhs of request at the 10 o'clock, they will deny because they want to maintain the safe sequence to satisfy the remaining customer's request. So this concept also they are using in deadlock only. Whatever the resources available with the system, if it is given to the first process itself, remaining all the process will wait for that resources. To avoid that one. Only part of the process depends upon their request. It will check with the availability. Then it will check with the is there any if we are satisfying that request to the process, whatever will happen to the remaining process, how many processes are there in system to continue to complete the programs, how many remaining processes are there, what are the request of resources to complete that one, that also it will check. If there is any sequence to satisfy all the process requests, then only it will allocate that requested resources to the first process itself. Otherwise, it will deny. That's why every time it will check for the safe sequence. What is safe sequence means? Whatever may be the order, in any one of the order, whatever may be the order in which all the process will complete its execution with the available resources. The order in which, not in a sequential manner, whatever may be the order may be it satisfies all the process requests, all the process will complete its execution. That sequence we are calling, the order of sequence we are calling safe sequence. So before allocating the resources, every time it will check for the safe sequence. So in exam also they will give you how many number of processes are there in the system at that time, what are the available resources, how many number of resources types are there, what are the available resources number, and what are the resources already allocated to that process, and how many number of resources it required to complete the every process request. That information it will give. In this example, I am giving number of process in the system is 5. P0, P1, P2, P3, P4. And at that time with the system, only 3 types of resources are there, and A type of resources are 3, B type of resources are 3, and C type of resources are 2 only available in the system. 5 processes are executing in that system at that time. These are the availability position of the system. This it will give in your question. And this system here we are considering in between all the process started the part of the execution. It is using multiprocessor system. Multiprocessor system means multiple programs are allocated to the multiple process. All the process started the execution with the available resources. That means already started the execution means before that only operating system is already allocated few of the resources to start the execution. These are the ABC resource types are only there in the system, and already operating system allocated for the pre-process only the B type of one resource to start the program execution. It is already in between of the execution, and P1 resource having number of 2 A type of resources, and B type it is not allocated, C type it is also not allocated to the P1 but started the execution. In between the execution it is completing its execution with the one processor with the 2 units of A resource type. Like that for every process, these are the allocated resource position. Operating system already allocated these resources. A type of resources, B type of resources, C type of resources to every process. After the allocation of these resources to the process, all are in execution position. Now with the system, only available are these. Is that clear? And to know that one system is in a deadlock position or it in a safe position, or it is there any safe sequence or not at this position. If process all will complete with the available resources or not, and in which order it will complete its execution, that we need to check. For that, we required information is maximum. That is also they will provide in exam. To complete process P0 execution, it required total A number of resources is 7, B number of resources is 5, C type of resource 3 units it requires. Like that for every process, this is the maximum requirement. To complete P0, it required A type of resource 4 units, B type of resource 3 units, C type of resource 3 units. But it already started its execution with the C type of resource only 2 units. It started the execution. But to complete the execution, these many resources it required. Like that for every process, maximum requirement means to complete that process execution, how many maximum requirements are required. That here we are specifying here. Now with the system, available resources are this. Now we need to check with this available resources, this process will complete the execution or not. To know that one, to complete process P0 execution, how many more resources it requires? It is having only 1 unit of B type of resources. And how many more resources it required to complete its execution, that will check. If it is available with the system, we'll allocate, it will complete the execution. Otherwise, we'll check with the P1. Otherwise, we'll check with the P2. Otherwise, we'll check with the P3. Otherwise, we'll check with the P4. Now, these are in current position. We'll check in any one of the order. If operating system will complete all the process execution with the available resources, and which order if it is allocates the resources, that we are calling it as safe sequence. That we need to consider now. To know that one, first we are checking with the need. Are few of your friends wrote this one as a work set or work queue? Work queue. That also we can consider. For P naught, how many more resources it require? A type or B type and C. It requires 7. And it is already having 1. Remaining 4 units if you are providing for this, total will get the 5 and it completes its execution. So that means how many more it requires? 7 minus 1. That is 4 more it requires. And C type of resources, how many it requires? 3 minus 0, it requires 3. Like that we need to calculate for every process how many more resources are required. In any one of the process, if it satisfies the need with the available, for that it will allocate the operating system to that process that resources. That's why first we need to calculate need. Till this point it is here we are getting mark. Clear till this point?
Yes, ma'am.
Yes. This one is P0, P1, P2, P3, P4. Okay, need. So we'll check for every process whatever the required resources are available with the system or not. So first we'll start with the P0. P0 to complete its execution, it requires A type of 7, B type of 4, C type of 3. With the system available, is satisfies its request or not? It requires A type of resources 7, but system is having only 3. Operating system not able to allocate that resources to that P0. Because if you allocate 3 for this P0, remaining 4 it requires, it will wait for that remaining 4 resources. It will changes that state from running to wait state. That's why it won't allocate. It won't allocate. It won't allocate to the P0. Then it will check if P0 will complete its execution or not. That will check. What is the need of what is the need of P1? A type of resource it required 2, C type of B type of resource it required, C type of it 2. We are having 3, 3, 3. A type 1, 3, okay, it can satisfy. It requires B type 2, it is having 3, okay. It is required C type 2, its system is also having 2. It can satisfy its request. If you are allocating these resources to the P1, it will complete its execution at a part, at a time, and it releases all the resources at a time. It releases all the resources at a time. With the available, individually we need to check A type resource, B type resource, C type resource. Individually we need to check. This is not a 3-digit number. 3-digit number. Every digit is related to a one resource type. That's why we need to check individually. We need to check individually. Clear, ma?
Yes, ma'am.
We need to check individually. So it will satisfying its request. Whatever the need is less than the available, that means it will allocate all this to this one. Whatever the maximum requirement is there, that available with the P0. That available with the P0. First it takes from one resource of A type from the system, two units of resource type B, 2 units of resource type 2. It will take from the system and it allocates to the P1. Now P1 will become as completely with the system 3, 3, 2 because it is allocated from available to this one. Available to this one means now P1 is having this one, and with the system it is having now only 2, 1, 0. After this with the P1 3, 2, 2, this one is 2, 1, 0. Now P1 is having complete information, complete whatever the maximum requirement is there. That means it is having maximum requirement of that one. That's why it will complete its execution and it releases all the resources. It releases all the resources means now P1 is having only 0, 0. Within time it will complete its execution. Within time it will complete its execution and it releases all the resources. Now available become for 2, now at the position it is having only 2, 1, 0. It releases 3, 2, 2. What is available position now means 5, 3, 2. P naught completed its execution. Now available position is 5, 3, 2. P naught completed its execution. Now in the system only P naught, P2, P3, P4. P naught, P2, P3, P4. If S means in that safe sequence, this is the available position and it is S safe sequence P1 already completed. After the completion of P1, this is the available position. This is the available position. Now we need to continue with the remaining process P2. What is the P2 need? P2 need is same because it is having this many only allocated. It requires this many to complete its execution. So P2 need is this one only. But our availability is increases 5, 3, 2. Check with that. This is A type, B type, C type. A type, B type, C type. A type it requires fixed, but we are having only 5. That means no. That means no. Till this point it is clear, ma? In safe sequence, P1 is completed. Now with the system P0, P2, P3, P4 is there. We are checking with the P2. P2 requires A type of resource 6. But we are having with the system only 5. That's why it is not satisfying the request of this one. It will stop. It will check with the continuity of P3. P3 it requires 0, 1, 1. And we are having 5, 3, 2. 5, 3, 2. Clear? It requires 0 of A resource. We are having more. It requires B type of resource only 1. We are having 3. It requires C type of resource only 1. We are having 2. So it satisfies the request. Need is less than this one. It satisfies this request. That means these many resources it will allocate to the P3 and it will complete its execution. It is having all the resources and it completes the execution. Then whatever the allocated resources are there, that it will add to this one. It will remove the allocated resources and allocates to this one. If it is satisfies means first we need to minus this one with this. We'll get 5, 2, 1 and with the P3 it is having 2, 2, 2. It satisfies the request and after that it will become 0, 0 and these resources will add it to this one. We are having now 7, 4, 3. First from the available, these many resources are allocated from system to P3. Then P3 will become like this. With the P3, all the resources available is 2, 2, 2. So then it will complete its execution. It completes its execution. It deallocates all the resources with then it will become availability with the system. That means with the P3 0, 0, 0 are there. These are added to availability. After the completion of P1 and P3, what is the next available here is 743. 743. This one also completed its execution. This one also completed its execution. This we need to check individually and write this one. Yes, P1 and P3 completed. This is the available position after P3. Next we need to check with the P4. What is the need of P4? 4, 3, 1. It is less than or equal to 7, 4, 3. 4, 3, 1. 4, 3, 1. All are less than only. 4 it requires, we are having 7. 3 it requires, we are having 4. 1 it is required, we are having 3. We are having 3. So that's why we can allocate these many resources to the P4 also. These many resources to the P4 also. So it's satisfying the request means yes. Again we'll do the minus of this one. Whenever it is allocating these resources from system to P4 with the available it will become 3, 1, 2 and this will become 4, 3, 3. After minusing this will allocate to this one with the 4. All the available systems are there. All the available systems are there. All the available systems are there. Is that okay, ma? Is it visible to you?
Yes, ma'am.
Okay, so all the available are there. That's why it will complete its execution, and after that it will become as 0 0 with the available. For 3 4 1 it will add 4 3 3. Then it will become 7 4 5. After the P4 completion with the system 745 resources are available. Now save sequence till this point. P1, P3, P4 are completed. P1, P3, P4 are completed. Whenever no, it will not allocate. P4 after this. P1 after, it is this one available. P3 after, this is the system availability. After P4, this is the availability of the system. Again, we need to complete, check the remaining process also. We need to complete the remaining process execution also. That's why we are continuing with the after P4, going back in circular manner. Again, we need to check with the P0. With the P0. What is the need of P0? 743 ABC. Now after this system, available resources are 745. Is that satisfying the request or not? We need to check. P1 completed, P3 completed, P4 completed. We're going back and we'll checking with the P0. P0 required 7, we are having 7. It required 4, we are having 4. It required 3, we are having 3. 5. So we can allocate. Operating system can allocate. So it is taking these resources, whatever the required resources from that system, and it is allocating to the P0. With the system it will become 0 while it is allocating these many resources to the P0. At that time, this is the position of available resources in the system, and with the P0 753, because these are all allocated to P0. 0 already it is having 0 1 0, and this is also we added. Now it is having complete 753. It will complete its execution, and after the completion of execution it will become deallocates all the resources of A type, B type, C type, and it will become as a 0. And now what is the after the completion of P0? After the completion of P0, what is the available resources position? Is need to add this 753 to this one, because it deallocates from P0 and it allocates to the system. Then this is the position after the P0 completion. After the P0 completion, now this is the available position with the system. And for save sequence, already P1 is there, P3 is there, P4 is there. Now P0 also completed. So if it completes P2 also, now system is in safe state. And what is the safe sequence? After this P2 also it completes means this is will become as a safe sequence. In this order, if operating system allocated the resources to the process, then system is deadlock free. System is deadlock free. So now with this position, with the available position, we'll check with the remaining process only P2. What is the P2 need? 1, 2, 2, A, B, C. But we are having 7, 5, 5. 1 it requires, we are having 7, it requires 2, we are having 5, it requires 2 type of 2 units of C, we are having this one. So we can allocate these resources to the P2, these resources to the P2. So after allocating, operating system after allocating this one, it is having, while it is allocating, it is having, this is the available, and these are all added to, already P2 is having 302, and also this also it is deleted and it is deallocated from system and allocated to the P0. Now with the P2 it is having, sorry, ma, I did the wrong now here. What is the P2 need? This one is 122 is P2. P1 need. Sorry, P2 need is 600. Sorry, ma. P2 need is 600. We are having 753. Anyway, it requires 6 units. We are having 7 units. Remaining 2, it isn't required. So anyway, it is having with the less than only with the availability it requests. That's why system will allocate this one. Sorry for that. I took this one. But remaining process only P2. P2 need is this one. So after this only resource type, it is allocated to the 6 units for P2. Remaining available is this one. Now P2 will become 9. Already 302 is with his already. So that's why total it is having now 902. It will complete its execution. It deallocates all the resources. Then it is added to system. 902. 902. It will add it to 153 to 902. Now with the system it is 1055. After the completion of P2 with the system it is having 1055. 10 is A, B, C and P2 also completed its execution. So whenever you are writing, no need of all these steps. If you are comfortable directly, you can write this availability after this every time, after this every time. Check yourself. Need with the availability every time, need with the availability and after the P2. Write the all those things. That's it. So system is deadlock free. This is the order of sequence. Operating system will allocate to the process, then all the process in the available, it will complete the execution with the available resources. If it is allocated the resources in this manner, in this sequence, first it needs to allocate the resources for P1, after that P3, after that P4, after that P0, after that P2. Then only its system is in deadlock free. Now system is in safe state. And what is the safe sequence means? P1, P3, P4, P0. In few times, in few questions, this in between, it may not satisfy the request. Then system enters into the unsafe and there is no safe sequence. If remaining process also not satisfying in any of the order, any process request is, any process need is not the less than availability, then it enters into the unsafe. There will not be available safe sequence. There will not available safe sequence. Is that clear, ma? So there you write all these every time. This one, if it is yes or no. Yes means what is the available? Last one. No means keep that one, continue with the remaining process. Because whenever you are starting in this example, P0 will get that, P0 we got that, no. Need is, so we continued with the P1. We got S here. Then after the P0 completion, this is the available sequence, available resources. And after that we checked with the P2. We got request no. Need is not the less than available. Need is more than the available. That's why we'll keep as it is. After this available only this one. Again we continued with the P3 checking. But need is less than available. Then it will become as S. After the completion of P3, this is the available resources. First available after P1. After that we got P3. After that P4. Just write need is less than. You are having that type of answer only na. Need is less than. And after the satisfaction of this one, what is the availability? What is the availability of the resources? That are only we are adding every time. So if it is satisfying this one, just add this whatever allocated to the available. That will make it as easy to you. Minusing, plussing, minusing, plussing. Subtraction, addition means instead of that, anyway P0 need first satisfied, no. P1 we said yes na. P1 need is first with the first availability. If it is S, it will allocate P for P1, write the sentence, allocate to the P1, completes P1 execution, After the completion of P1 execution, P1 is having 0, 0 and available become 3, 3, 1, 2, 2, 4, 5. Like that also we can write. Check with that. Every time complete that and write that one. Allocated one, need one, if it is there, then you can check with that and write the available resources as it is according to that one and continue with that. Anything required revision after this? Theory or any problem? Page replacement or CPU scheduling, anyone required? Problems? Or any other topic? CPU scheduling. Okay. In CPU scheduling, which one you required particularly? Any particular problem or all CPU scheduling algorithms? Someone said FIFO page replacement. Okay. All CPU scheduling also required, ma. Shall I continue class with this topics? SAF scheduling particularly, few of them required, and page replacement. Okay, ma, I'll continue till 30 more minutes, okay? No, ma'am, only clarity with arriving times. Okay, with the arrival times, you require CPU scheduling. And page replacement, only one student asked about the page replacement. Yeah. Is any other person also require page replacement, ma? All page replacement, ma. Okay. So I'll start page replacement first. After that, CPU scheduling problems also with the arrival times 1-1 scheduling algorithm. I'll give you, ma. Okay. So page replacement. When we require the page replacement means complete main memory is divided into the fixed partitions, that is frames. For every program also it divided into the logical blocks, that is pages. Pages and frames both are same size. Frames, why we are calling the name frame is to understand it is a physical device, hardware device, main memory device. Logically, that program is divided into the pages. Pages and frames both are same. But in logical, pages we are calling, in physical we are calling it as frames. Physically, where we are storing that name, that block partition name is frame. Logically, what we are watching at, what we are looking, that is page. Same thing. Physically, wherever you are writing, and logically it is page. CPU generated one, logical one, that is logical address, logical frame. Physically, whatever the exact location of that one, that we can call it as physical address. So, whenever the complete related page, every program depends upon the size. It may require 3 pages, 4 pages, 10 pages, 15 pages, 20 pages. Physically, it is same, both are same. But according to the cost of the main memory, in system, whatever may be the system, they'll maintain only the limited size of main memory. Speed is more, but cost is also more. Whatever the material used for RAM, main memory, that is very costly one. But transferring of the data is comparatively with the hard disk, it is little bit more. That's why to allocate that data to the CPU temporarily wherever you are storing, it won't maintain complete program in the main memory. Only part of the program it will maintain. For every program, depends upon the difference on the program size, it may allocate 4 fixed partitions or 3 fixed partitions. But how many number of pages depends upon the program size, that many pages it may require. So, to complete that program execution, what is the first page reference it required? What is the second page it requires? Because depends upon the programming languages, we may write C programming language or Java programming language. For few programs, we'll write the main function in the first page itself. For few programs, we'll write the main function in the last page. Whenever you are particularly using the Java type of programming language, we'll write all the class and objects. Last, we'll write the main function. but program starts the execution from the main function only. Maybe depends upon the programming language. This main function may be available in the page number 1 or page number 9 or page number 7. But program will start with the main function only. That's why it needs to first refer the page number 9. After that, depends upon the set of instructions to complete that program execution. It may refer any page number. Any page number. So to know that one, to complete the program execution, what is the page number sequence is required, that we are calling memory references. That complete references will give it as a one set, that we can call it as reference string. Reference string. So for example purpose, I am taking these are the page numbers required to complete the program execution, to complete the one program execution. So these are the page numbers it require. This we can call to complete the program execution. First it needs to refer page number 7. After that page number 0. After that page number 1. So complete program it is in 8 pages from 0 to 7. But to complete the program execution in this sequence, these we can call it as memory references. This complete set of memory references we can call it as reference string. Reference string. But we said main memory space is very less. That's why it won't allocate 8 fixed partitions for this program in main memory. It may allocate 3 or 4 sections of 3 or 4 sections, 3 or 4 memory only pages we can accommodate at a time in the main memory. So whenever you require according to your request, in that only we need to replace. That we are calling page replacement. So in this example, I am taking 3 frames. Physically, 3 fixed partitions are available in main memory for this program. But program is having 8 pages from 0 to 7. To complete the program execution, this is the sequence of pages. Reference of pages it requires to complete the execution. So in main memory we said only 3 frames are allocated for this. First these 3 frames are empty only. We need to transfer this one from hard disk to main memory. Then only we can allocate to the CPU. First it is having 3 frames, 3 places. 3 frames are empty, 3 positions are empty. First we require 7th page, that's why we transferred from 7th page from hard disk to main memory. Page is first not available in the main memory. That we are calling it as with the name page fault. Page fault. Here with the page replacement algorithms, how many page faults are there? If less number of page faults are there means with that it will take less time to complete the execution. Whenever page is not available, every time we need to swap that page frame, move that page from hard disk to main memory. For that also it will take the time. So we'll get the response with late. If pages are available in the main memory, we'll get the response within the less time. After this, I'll continue with the CPU schedulings also. I'll complete within the less time, 10 minutes I'll complete with this topic. After that, I'll continue with the CPU scheduling algorithms. Clear? Is that okay, Ma?
Yes, ma'am.
Yeah, I'll continue with us. So, every time whenever the page is not available, that we need to replace. First empty frames are there, that's why we are swapping according to the request. 7th page is required. So, there are 3 page replacement algorithms are there. FIFO, optimal, LRU. I'll complete within the less time, 10 minutes only. After that, I'll complete that CPU scheduling also. There are 3 type of page replacement algorithms, FIFO, optimal and LRU. According to the FIFO, first in, first out. Which page is first entered into the main memory? Whenever new page is required to complete the execution, that page we are calling it as demand page. Whenever the page is not available, to complete that, whatever the page is required to continue the execution, that page we are calling it as demand page. So if it is page is not there, that then we need to replace. For that there are 3 algorithms, FIFO, optimal and LRU. FIFO is first in, first out. Which page is first entered into the main memory, that we replace with the new requirement, that is FIFO. First anyway 7th page is required, that is not available. We moved from 7th page from hard disk to first frame. After that page number 0 is required, already 7 is there but 0 is not there, but empty frame is available, that's why we moved 0 from hard disk to main memory. Next requirement is 7. We checked it, already we are having 7 and 0, but we are not having 1. So that is page fault. But empty frame is available. That's why no need of replacement till this point. So till this point, there are 3 page faults occurred. 3 misses are there. 3 misses are there. 3 page faults. 1, 2, 3. These 3 pages are not available in the main memory. We swap out these pages from hard disk to main memory. Next, to continue the program execution, it required 2. It required 2. We are having only 701. Second page is not available. To continue that one, we need to replace any one of this. First, we are following FIFO. What is FIFO? Which page is first entered into the main memory? That we need to replace. In these 3, which page is first entered into the main memory? 7. In these 3. That we replace with the 2. Clear, ma?
Yes, ma'am.
Okay, ma'am. That we replaced with the 7 with the 2. Next required page is here. Page 2 also not available. That's why we replaced 7 with the 4. That is 4. Next page fault is 4 only. Next, to continue the execution, it required 0. Already it is available in the main memory. No need of that one. This we will consider it as hit. Hit. Page is available. That means hit. Not available, fault. Next required page is 3. 3 is not available. In main memory 201 is there. 3 is not there. That's why we need to replace any one of this. In these 3, which one is first entered? So this one is last entered one. Before that,
0,
1.
ma'am.
1. In these 3, this first entered one is 0. That's why we are replacing 2 already there, 0 we are replacing, and 1. So here it is, page is not available. That's why we replace it that one, page fault. Next required one is 0. 0 is also not available. Then also we need to replace in these 3, which one is first entered. 1 is in these 3, 1 is first entered one. So in these 3 frames, we are replacing 1 with the 4. That means we need to write here. Now within the main memory 2, 3, 4 is available, and here it is page fault occurred, 6th page fault. 0 is sorry, not 4, 0 na, sorry, 2, 3, 0, 6th page fault, this one, 6th page fault. Next one is 4, required one. 4 is also not available. We need to replace these 3. Within these 3, which one is first entered? In these 3, that we need to check. That we need to replace. In these 3, 2 is the first entered one. That's why we are replacing this one with 0. Like this we need to continue. Is that clear for FIFO? I need to complete that program, problem also. Shall I complete or leave this one?
No need, ma'am. No need.
No need, na? Okay. This is the FIFO. Next one, optimal. Optimal, every time we need to check with the future. First frame, 7th page is not available. Anyway, page fault. So next, 0 is also not available. This is also page fault. Next available is 1 empty frames. 3 frames are there. 3 empty frames. Still the 3 empty frames. No need to replacement, but page is not available. That we will consider as a page fault. Till this point, it is same for all the 3. Next one is optimal time. Optimal time, every time we need to check which page is not required in near future. In these 3, which page is not required in near future, that we need to replace. Next page is required is 2, but it is not available in the main memory. So we need to replace any one of this page. We said according to optimal, which one is not used in near future. Near future it requires 0. After that 1, also in near future it requires. Longest future it requires 7. That's why we are replacing 7 with the new page. Near future it requires, after that it requires 1. Only the longest period, after the longest period of time required only 7. That's why we are writing here this one. And we replaced one page, that's why it is page fault. Page is not available. That's why we are considering this one is page fault. Next required continuation is 0. 0 is already available in the main memory. This we can consider as hit. Next we'll check with the reference string with the 3. 3 page is required, but it is not available in the main memory. It is not available in the main memory. Again we need to check within these 3 pages which is not required in near future. After this only in near future 0 is required. After that in between 2 and 1, which one is in near future it required? 2. 1 is not required in near future. Comparing with these 3. 0 in near future requires. After that it required. After that it requires 2. After that maybe the 1 here. So in near future it requires second 0 page and also second page. That's why this one we are replacing with this page. With this page. So now this one is. Now main memory position is 203. And this one we will consider as page fault number 5. After that required page in reference string is 0. It is already available, hit in main memory. Next required is 4. It is not available because we are having 203. 4 is not available. That is will become as a fault. But we need to replace that one. Same concept which is not required in near future. In near future it required 2. After that it required 3. That's why we are replacing this one. 243. 243. Page fault 6. Next required 2. Already there. Next required 3. That is also already there. This is hit. This is hit. This is hit. This is hit. Next required page is 0. In these 3 which is not required in near future, that we will replace. In near future it required 3. In near future it required 2. Which one is not required in near future? 4. So we'll replace 4 with 0 and it will consider as page fault 7. Clear ma this one? Are you able to understand till this point? Yes ma?
Yes, ma'am.
Okay, shall I continue with this or stop here? We are having less time now, that's why I am asking. Here we will
Enough,
continue.
ma'am.
Enough now? Optimal. Every time we need to check near future. Optimal. Every time we need to check near future. Okay. Again we can continue with the next one with the LRU. Same 3 frames. 3 frames are empty at that and no page is available. Till that point we can write it like this only. Till fill the 3 frames, 3 page false. And according to the LRU, every time we need to check past history, which is not referred, least referenced, least used. LRU least recently used one, that we need to replace. Recently we used the page number 1. Recently we used the page number 0. This one, this frame we recently referred. After that this frame we recently referred. Longest time in these 3 is this one. Then whenever the page is not available, that we need to replace here. So 2 is replaced with 7. So this one also one consider page fault. Next 0 page is there, hit. Next 3 page fault, not there. Again we need to check past history. Recently referred one this. Recently referred one this. Before that referred one this. So longest period of time in these 3 is this one. So we replace 203. 1 with the 3. Recently referred one is we are leaving that one. Least recently, longest period of time referred frame that we are replacing. So recently referred page this, before that this one, after that this one. Next one hit, because it required 0. 0 is already there. Next required page is 4. 4 is not available. Again we need to check which one is recently referred. This frame is recently referred one. After that, this frame is recently referred one, recently referred page. 2, comparing with these 3, 2 is longest referred page, not recently used one. That's why we are replacing 2 with 4 and we are writing this one also page 1. Page replacement, page fault is there. Like that. Next we'll check with the 2. 2 is not available. Again we need to replace any one of the page which is not referred recently. Not referred recently. Least recently means longest period of time referred. So that we need to check. So whenever now we require 2. But recently referred one, this frame, because page we referred. After that recently referred one, longest one, 3. So here we write 402 and this page fault is 7. This page fault is 7. Next required page 3. Again 3 is not available because now only we replace it that one. Now only we replace it. Depends upon the past history. Depends upon the past history. But now it requires 3. Again we need to replace. Which one we need to replace? Which is not referred recently. Referred recently is 2. Before this. Now we are at position this. Before this we referred second page. Before the 2 we referred page 4. But that's why we are replacing this 0 with 3. This is also considered page fault 9. Like this we need to continue with the LRU. Clear?
Yes, ma'am.
Every time past history we need to check. Every time past history we need to check. Clear, ma? Shall I stop this one here?
Yes, ma'am.
Okay, next topic is which one you required? CPU scheduling. Most of them asked about the CPU scheduling. In that, which one with arrival times you required the problems with arrival times, no? With arrival times, and also which one is you required exactly? Is there any particular SJF and priority you required? FIFO, is it okay? Sorry,
Yes,
FCFS.
ma'am. Yes, ma'am.
Worst scheduling algorithm is CPU scheduling algorithms. What is the meaning of CPU scheduling algorithms? Is in main memory which program you want to complete its execution, that we are moving, swapping that program or moving that program from hard disk to main memory. In main memory also multiple processes are available. Within that, which we need to allocate first for the CPU. CPU only completes the execution part. Remaining all, we are simply transferring the data from one place to another. But CPU will do the actual process. So for which process we need to allocate for the CPU first execution, that depends upon the one technique, few techniques. That we are calling it as CPU scheduling. For that CPU will allocate, process will allocate to the CPU. There are few techniques are there, FCFS, SJF, priority, round robin. Before going to this technique, again 2 types of methods are there for CPU allocation and deallocation. That is pre-emittive and non-pre-emittive. What is pre-emittive means? Before the completion of execution only, CPU is deallocated from that process and it may allocate to the another process. Non-pre-emittive means once the CPU is allocated to that process, till the completion of that program, CPU is with that only. Whatever may be the priority, whatever may be the disturbances, then also CPU will continue with that process till the completion of execution. That we can call it as non-pre-emittive. This type of scheduling is allocated to the FCFS. What is the meaning of FCFS means? First come, first serve. First serve. Whatever may be the first request, for that CPU will allocate, and till the completion of program it is with that process only. With that process only. After the completion only it will continue, which is next arrival into the main memory. That is FCFS. SJF means which process required less CPU time. For that only it will allocate. That is shortest job first. Which process required CPU time less. at that time. For that only it will allocate CPU. And for this SJF, there are two types. Maybe depends upon the shortest CPU required time. CPU may allocate it to that one. But after that, one more process entered into the main memory, which is required less time. Whichever now CPU is allocated for with one process, but next arrived processes have required less time comparing with this. Then automatically it deallocates and allocates to the next one. That is preemptive. If it is following the type of technique non-preemptive, once it is what within the available system, within the available process, which is having less CPU, which is required less CPU time, for that it will allocate until the completion it won't deallocate. So SJF is having these two type, priority also following these two type of techniques. Whereas round robin, in round robin for every process, fixed time scheduling, fixed time slot it will allocate. Depending upon that time slot, it automatically deallocates from that process and continue with the next process in the ready queue. It's continue with the next process in the ready queue. That means always round robin is always preemptive. FCFS is always non-preemptive. These two, pre as well as non-preemptive. Depends upon the technique or user requirement. Now I am giving the one example for the shortest CPU time, shortest job first, same preemptive as well as non-preemptive. Preemptive as well as non-preemptive with arrival times I will give you. So simple example. I'll write here process number, arrival time as well as burst time. The burst time is here it is CPU requirement. P1 process, P2 process, P3 process, P4 process, P5 process, P6 process. And arrival times here is 0, 1, 2, 3, 4 and 5. These arrival times here I am giving relative times, not the exact times. Is that clear? To understand the problems, generally we will use the Gantt chart. SJF, I am writing Gantt chart here with the relative times 0. It will start relative time 0. To understand the problem, we are starting with the Gantt chart. These many processes are available in the main memory and these are the arrival times, at what time it enters into the main memory and what is the CPU requirement. Now we'll start with the first non-preemptive. Non-preemptive means according to that once the CPU is allocated to one process till the completion of that one, it won't allocate, it won't deallocate from that process. Is that clear? Is that clear,
Yes,
ma'am?
ma'am.
Yeah, ma'am. So every time we need to check the main memory. How many number of processes are there? At relative time. At relative time 0, only one process is available in the main memory. So automatically CPU will allocate to the process 1. CPU will allocate to the process 1. It started the execution. And according to the non-preemptive, till the completion of that one, it won't deallocate. How many units of time it required? 8 units. 8 units of time. Till that time, it won't deallocate CPU from that. But in between, P1 started the execution at relative time 0. After 1 minute, it is continuing with the 1 unit of execution. But in main memory, it entered one more process, P2. At relative time 2, it entered one more process into the main memory. At relative time 2, in main memory, it is already at relative time 0, only one is available. This one is allocated to the CPU. Now in the main memory, there is no process. But at relative time 1, P2 entered. At relative time 2, P3 also entered. P2 is already in the main memory. P3 also not now available in the main memory. At relative time 3, one more process entered into the main memory, that is P4. That is P2, P3, P4 is not now available in the main memory. CPU is continuing with its execution of 1 unit of time, second unit of time, third unit of time. till it is continuing with the P1 only because it is a non-preemptive. Next, relative time 4. P5 also entered into the system. In main memory, P2, P3, P4, P5 all are available. At relative time 5, P6 also entered. So in main memory, P3, P4, P5, P6, these many processes are in waiting in main memory for the CPU allocation. But CPU is with the P1. It is continuing with the execution. 5 units of time over. Next, 6th unit, there is no process entered. But CPU is with this only. 1, 2, 3, 4, 5. Till that time, this many process entered. 6, 7, 8. Now CPU completed its execution of P1. All are completed its execution P1. Now it will check, operating system check how many processes are available in the main memory. These many processes are available in the main memory. According to the SJF, which required CPU time less, for that it will allocate. So in these P2, P3, P4, P5, P6, which require less CPU time? Which process require less CPU time, ma?
P6, ma'am.
P6. So it will allocate for P6. How much time it required? Only 1 unit. So relative time 9, it will complete its execution. But at relative time 9, is there any other process entered? No. P6 also completed its execution. P6 also completed its execution. In the main memory, now available process P2, P3, P4, P5. So it continues with that remaining. In this, which one is required? Less one. So after P1 completion, after P6 completion, which one is less, ma? Which process required less
P4,
CPU?
ma'am.
P4. After that, so how much it required? 2 units, 11. After that, which one is less?
P5, ma'am.
P5. So next, P3 and
Either, ma'am.
P2.
P4.
So P4 is also completed its execution. P5 also completed its execution. Remaining is P2 and P3. Both are required 6 units of CPU time. But which one is first entered into that one? Main memory?
P2, ma'am.
P2. That's why it allocates for P2. Next allocates for P3. All the process will complete its execution. All the process will complete its execution. Gantt chart here it will give, this is the starting time, this is the ending relative time. That will consider as a completion time. That will consider as a completion time for every process. P0 after this P5 is 3 units, that means here Gantt chart is 14. Next one is P2 entered one. It requires 6 means 20. Next one 26. To complete all the process execution, it started at relative time 0, completed at 26. But to calculate the average waiting time and average turnaround time, what is waiting time? How much time it spends in main memory for the allocation of CPU, that we are calling it as waiting time. And what is turnaround time? From the arrival, from the relative time of arrival till the completion of program, how much time it spends, that we can call it as turnaround time. How much time waiting for CPU allocation, waiting time. How much total time spends to complete the process execution from the arrival to this one, that we can call it as turnaround time. So with the Gantt chart, we'll get that completion times. P1 completion time is 8, P2 completion time is 20, P3 completion time is 26, P4 completion time is 11, P5 completion time is 14, P6 completion time is 9. To know the how much time it spends in the system to complete the program execution, is formula is TAT minus CT minus AT. Sorry. CT minus AT. And here TAT minus BT. These are the formulas to calculate waiting time and turnaround time. You can calculate all these things and write average waiting time and average turnaround time. To increase the number of steps, no need of writing here. Calculate here every time, every step. For P1, what is the turnaround time, and after that fill this. P2, one more step. To get the more marks, more steps in external paper. Calculate here step by step. After that, fill this table. Clear this one? Non-preemptive. Only I'll tell the preemptive within the 10 minutes, ma. After that, we'll continue with the file or directory implementation. Few members asked about me that one. Shall I continue today itself here? 10 more minutes. Otherwise, tomorrow we can continue. Depends upon you, ma. If you are okay with that, I'll complete this one. Only this topic today. After that, whatever the topics you require, tomorrow shall I keep the same thing as a Zoom meeting? If you require, I can continue tomorrow also for the revision class. Shall I continue now? Preemptive, because class started at 7. Now it's time now 9. Is it okay? Preemptive scheduling? Otherwise, tomorrow we'll continue. Shall I continue tomorrow, ma? CPU schedulings and whatever the theory parts you asked about me. File and directory. Is that okay to everyone? Few members they said yes, ma'am, tomorrow. Yeah. Shall I stop here? Yes, ma'am. Same thing. Same time. Is it okay for you tomorrow also? 7 to 8. Tomorrow I will complete within the less time. 7 to 8. Maybe because most of the problems today we covered. Otherwise, if you don't require these problems, theory part only morning time I will keep. You require problems, then only I will keep same time. Is that okay? Same time tomorrow also? Okay, ma'am. Now I am leaving this one. Tomorrow 7 to 8 same time. I'll continue with that. Same. I'll share you link and we'll continue CPU scheduling and file and directory implementation. Few of the students they asked about me 5th unit file and directory implementation and structures. That I'll continue in the tomorrow. Okay, ma'am. Thank you. You can leave the class.
Thank you, ma'am.
Yes, ma'am. Yes, ma'am. You can leave the class. I'm also closing that meeting. Tomorrow we'll continue with the same time.